Good morning once again and welcome to my YouTube channel, Pearson and Excel International Maths. And in this video, we continue to understand integration, and I want us to say something about indefinite integrals on P1, page 173. And we are told that you can use the symbol elongated S to represent the process of integration. You can use that symbol. Anytime you see this symbol, please note that you are expected to integrate. For example, if we integrate the differential function with respect to x, this one should give you fx, the function itself, plus c. This is just what we are talking about. At the same time, if you integrate something to do with x raised to power n with respect to x, then you are expected to have xn plus 1 over n plus 1, of course, plus c. And remember, n is never supposed to be -1 for obvious reasons. When you are integrating a polynomial function, you can integrate the terms one at a time. Polynomial function means that you need to integrate one term after the other. And that is exactly what is expressed in bold on page 73. But I just want to go to example 4 because it's going to show polynomials. Example 4, let's talk about example 4. Now, integrate x raised to power a half plus 2x cubed with respect to x. And what does this give us? This simply gives us x raised to power 3 over 2 over 3 over 2. Remember, the power increases by 1. It was half, now it should be 1.5, which is 3 over 2 plus 2x raised to power 4 over the new index 4 plus c. What you just need to do is to just clean up this a little bit and talk about, we have talked about when we divide by a fraction, it so means that we multiply by the reciprocal of the fraction, which is definitely 2 over 3 multiplied by x raised to power 3 over 2. Of course, this is 2 over 4, which is a half, x raised to power 4 plus a constant c. And that is the end of that part. If this is part 1, we could have part 2 here, which is talking of integrate x raised to power minus 3 over 2 plus 2 with respect to x. And it goes without saying, this is going to be x. This is minus 1.5 plus 1 is minus a half over minus a half plus 2. X was raised to power 0 here, so the power increases by 1, x raised to power 1, of course, over 1. Let me just put it there for the sake of understanding, plus the constant. Cleaning up a little bit now what we have, dividing by a fraction reminds us that we should be multiplying by the reciprocal of the divisor, and the reciprocal of has is simply 2, and because it is negative, we have minus 2. X raised to power minus a half plus 2x plus c. And that is just what we need to know as far as that part is concerned. Let's look at part 3 of the same. We need to integrate p squared x raised to power minus 2 plus q with respect to x. This is very important, and I want us to listen to this. the fact that we have p squared and x in the same term, it doesn't mean that now that p squared is a variable, we should integrate with respect to p. What matters so much is what have we been told? What are we integrating with respect to? So we are supposed to integrate with respect to x, and as such, p squared should simply be treated like a constant, and that is what we're going to do. So the integral of this is p squared x raised to the power minus 2 plus 1 minus 1 over minus 1 plus qx, of course, plus c. If we clean up this, then you're going to have minus p squared x raised to the power minus 1 plus qx plus c. And that is our final submission as far as that one is concerned. Minus p squared x raised to the power minus 1 plus qx plus c. And let's look at part 4 of the same example 4 and have it this way. Integrate 4t squared plus 6 with respect to t. And I want us to be very keen here. And this one is teaching us something new, that it is not a must that we integrate with respect to x. Sometimes we will be expected to integrate with respect to a completely different variable. In fact, you will find some relationship of some functions that do not have x. For example, the relationship of velocity and time, you will not find x. You will find v, you will find s denoting the distance, you will find t denoting time, you will find a denoting acceleration. So if you're waiting to integrate with respect to x, then you might not get through, especially when you get functions that are not having x. So yes, we can integrate with respect to different variables depending on the nature of the function. So here we are integrating with respect to t, and just normally is going to be 4t cubed over 3 plus 6t. Of course, when the is born, then this one, cleaning it out a little bit, is going to give us 4t over 3 plus 6t plus c, and that's like it. In fact, we have had that one, we have had that one, we have had the second one, and we have had the fourth one. Note that all of them are having a c as a constant of integration. Probably next time, or in the next example, which is example 5, we're going to go deeper to integration, indefinite integration. For now, let's go through. Visit my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. Make sure you subscribe and you share, and let's work together. All right.